All right, so let's see how this actually works on our on some problems. So we talked about the fact that when the first derivative is positive, our function is increasing. When the first derivative is negative, our function is decreasing. So we know that when the slope of the tangent line, which is our derivative, is positive, then our function is increasing. Okay, so let's figure out how we can look at some functions and find things like that. Okay, so I just have some steps here. The first thing you're going to do when you're trying to find our relative extrema, okay, so we're trying to find spots where it changes direction, right? Like some peaks and some valleys. We're just trying to figure out where those are. We find any domain restrictions. That's our first step. Then our second step is we find all of our critical numbers. So we know how to find critical numbers. That's where f prime of x is equal to 0 or where f prime of x is undefined. And so remember, though, that domain restrictions cannot be critical numbers. So if your function is undefined at, say, x equals 3, then it cannot be a critical number because your function doesn't exist. So a critical number, if you remember the definition, is where the derivative is equal to 0 or undefined and f of x exists. Okay, so we'll see that in one of our examples. So if that just totally went, whew, that's okay. So critical numbers are where f of x exists and where the derivative is equal to 0 or undefined. So we're going to do all of our critical numbers. Then what we're going to do is take those critical numbers and our domain restrictions. We're going to do what we call an f prime number line to figure out what's going on with the function. And then we're going to test it to see whether the function is positive or negative, whether the derivative is positive or negative at each of those points. And then find out what's happening, and then we'll be able to figure out the increasing and decreasing intervals and our max and mins. So let's look at this in real practice. Okay, so find the intervals on which these functions are increasing and decreasing and find all local extrema points. Okay, so we're going to find the points, which means, you know, anytime you see the word points, you know that's an x and a y, right? So this isn't just like, oh, the extrema is 5. Like, that doesn't work, right? So we got to do points. Okay, so we're going to find points of the local extrema. Okay. So let's start with this one. The first thing that we need to do, if we look at our steps, the very first thing we need to do is find all of our domain restrictions. Okay, so is this one defined on all parts of its domain? Well, remember, we can't take the square root of a negative number. We can't divide by 0. And there's nothing in a denominator here. And we're taking a cube root, not a square root. And we can take cube roots of negative numbers. So in this case, we have no domain restrictions, so our domain is all real numbers. So great, no domain restrictions. So next step is to find all of our critical numbers. So let's find our critical numbers. So that's step number 1. We can go to step number 2 here, is finding our critical numbers. Okay, so our critical numbers are where the derivative is equal to 0 or undefined. So let's find the derivative. F prime of x equals 2/3 x squared minus 9. This is a chain rule situation. Times the derivative of the inside, right? So I did the derivative of the outside with the inside still intact times the derivative of the inside. Okay, so that's a chain rule. So then we get that f prime of x equals 4/3 x squared minus 9 to the negative 1/3. And in this case, we can just rewrite it so that we can look and recognize where it's undefined. We're going to rewrite it as a fraction. Sometimes that makes sense, sometimes it doesn't. Sometimes you have to just try it and see if it makes sense. And if it doesn't help you, then no big deal. You just got some practice in writing it a different way, right? Okay, So if we write this as a fraction, then it's a little easier to see where, oh, sorry, I forgot my 4x. Yeah, forgot my 4x. Okay. Okay, we can see where it's equal to 0 and where it's undefined. So remember, I'll put this right here. If the numerator is equal to 0, then f prime of x is going to be equal to 0, right? So that's when we want to find when f prime of x is equal to 0, we look at the numerator. What is the numerator doing, okay? When the denominator, I don't think I'm spelling this right. Anyway, it's fine. Not worth it. When the denominator is equal to 0, f prime is undefined because you can't divide by 0. Okay, so this is what we check for. We check when the numerator is equal to 0, f prime of x is equal to 0, and when the denominator is equal to 0, f prime of x is undefined. So we're going to say, okay, when is our numerator equal to 0? So f prime of x is equal to 0 when 4x is equal to 0. Therefore, we could solve this by dividing both sides by 4, but we know then at x equals 0, then the numerator is equal to 0. So that's when it's equal to 0. Now let's see, f prime of x is undefined when 3 times the cube root of x squared minus 9 is equal to 0, right? When our denominator is equal to 0. So we divide both sides by 3, and we have the cube root of x squared minus 9 equals 0. And when is this going to be equal to 0? Well, you know, I'll do the algebra. I'll just do the algebra. You might be able to look at it and say, oh, when x is plus or minus 3, this is equal to 0. But let's just do the algebra in case you don't see that. So we're going to cube both sides to get rid of that cube root. And we have x squared. Oh, it's behind my head. I just realized. Okay. There you go. So we're going to cube both sides. And now we have x squared minus 9 is equal to 0. So then we add 9. And we get x squared equals 9. And then we take the square root of both sides. And we get x equals plus or minus 3. Okay? So, f prime of x is undefined when our denominator is equal to 0. And we know our denominator is equal to 0 at x equals plus or minus 3. So, we can now definitively say our critical numbers are at x equals 0, negative 3, and positive 3, okay? Because that's where our derivative is either undefined or equal to 0. So now what we're going to do is we do a little thing called the f prime number line. So we look at our f prime and we figure out what's happening before and after each of our critical numbers. So we use our critical numbers and we use all of our domain restrictions as well. But we don't have any domain restrictions on this one, so we're just going to use our critical numbers. So our critical numbers are negative 3, 0, and 3. So let's figure out what's happening before and after each of these critical numbers. And we're looking at what's happening to f prime, okay? Because f prime is going to tell us what's going on in the function. So when f prime is equal to, say, negative 4, well, let's look at what f prime is. So when f prime is equal to negative 4, I would put negative 4 in here, and I would get, let's see, f prime of negative 4, so this is less than 3. Honestly, less than negative 3, you could pick any number. You could pick negative 100, you could pick negative 1 million. As long as it's less than negative 3, that's all that matters, okay? So f prime of negative 4 is going to give us negative 16 over 3 times the cube root of 16 minus 9. So all that we care about is whether this is positive or negative. I really don't care about the value. So we look and we have a negative on top, and this on the bottom is going to be positive because 16 minus 9 is bigger than 9, or 16 is bigger than 9, so that's going to be positive. So we have negative on top, positive on bottom. So I know that below negative 3, f prime is not positive, is negative, because we have negative on top, positive on bottom. So f prime is negative when it's smaller than negative 3. Okay, now in between negative 3 and 0, what's happening to f prime? Well, f prime negative 2 would give us a negative 8 on the bottom, and then we'd have 3 times the cube root of 4 minus 9. Now you notice that that's 4 minus 9, that's a negative number, and we can take the cube root of a negative number. That's totally fine. We just end up with a negative number. So we're going to have a negative on top and a negative on bottom, which gives us a positive. So in between negative 3 and 0, we have a positive. We have positive values. In between 0 and 3, well, we would put in f prime of 2, let's say, or 1. Actually, 1 would probably even be easier to do, but it doesn't really matter. So it's positive on top, and then we have 3 times the cube root of 1 minus 9. So it's positive on top, and 1 minus 9 is negative, right, because it's smaller than, 1 is smaller than 9. So we're going to have a negative on the bottom. And then really quick, while I'm already up here, I'm going to say f prime of 4, because we want something bigger than 3. So f prime of 4 would be a positive on top, and then 3 times the cube root of 16 minus 9. So it's going to give us a positive also on bottom. So I can say in between 0 and 3, f prime is negative, and in between 3 and infinity, it's positive. So now all we have to do is figure out what does this actually mean for our function. Okay, what does this mean for our function? Well, it means that before negative 3, our derivative is negative. So if you go back to your foldable, the derivative is negative. That means that the function, our actual function, is decreasing. Okay, we can just write it like that. Now, when f prime is positive, that means our function is increasing. When f prime is negative, that means our function is decreasing. And when f prime is positive, it means our function is increasing. So that means that we have, this is kind of the pattern of our function. And then we can also look at this and see that we also know from our foldable, you have it right here. You probably don't have it at home right now, but that's okay. F has a local minimum if f prime changes from negative to positive. So you see right here where it changes from negative to positive, that means this is a minimum because it changed from negative to positive because it went from decreasing to increasing. Then when it changes from positive to negative, that's a max. And then when it changes from negative to positive, that's a min. So what are our local mins and maxes? Well, at x equals negative 3 and at x equals 3, we have a minimum. So let's figure out the points for that. And then at x equals 0, we have a maximum. So what are the actual points on our graph? Well, when x equals negative 3, so we go to f of negative 3, and that equals 9 minus 9 to the 2/3, which is 0. And then f of 3 is, f of 3, I'm hurrying because I only have like 30 seconds left. 9 minus 9 to the 2/3, which is also 0. So we have a min at negative 3, 0 and positive 3, 0. And we have a max at when x equals 0, we have negative 9 to the 2/3. So our max is 0, negative 9 to the 2/3. and it's going to cut me off in 5 seconds. So there you go. We will look at some more in the next video.